Welcome to this conversation here at RISE, Computer Science and AI. My name is Martin Schörling. I'm a senior researcher at RISE. With me, I have Saif Haridi, professor at KTH, also senior leader at RISE. And we have the absolute honor today to have as a guest Ali Ghodsi, CEO of Databricks. Databricks is, of course, one of the most talked about companies in Silicon Valley right now. And it's welcome, Ali.
Thank you.
And Saif and I were just joking that we could have a competition on making a nice intro about you. But I think we want to hear from you yourself, your amazing journey that actually started here at KTH and SIX that then became RISE. So please take it away, Ali.
Yeah, I showed up, I think, in the early 2000s at SIX. We were it was a tail end of programming language research that we were doing. But I was kind of interested in another research area that also Saif and others in the group were also active in, which at the time was peer-to-peer computing. And the reason for that is that peer-to-peer computing, it was distributed systems, it was the internet, it was computers interconnected all over the world and so on. And we just were excited that maybe this is the future. Maybe in the future, we're going to see more and more of these distributed applications. So my PhD work started with Saif at the SIX group on distributed systems. And it was exciting years. And actually, it turned out we were kind of right that the next wave of software systems were going to be distributed. Those were formative years for me. So I was lucky to sort of, right time, right place, do research on the right topic that eventually would become, the main thing here in Silicon Valley was at the time, all these startups were starting in 2008, 7, 9, you had, Airbnb, Uber, Twitter, all these companies were starting. And what did they need? They needed people that understand distributed systems, who understand how you can build software that scales into data centers. So that's kind of how I got my start back at SIX.
So Ali, you moved from Berkeley in a research group, and you started with other researchers, Databricks as a company. But under your leadership, the company has been transforming from, say, a managed cloud platform for Spark and its application to become a general data company. Can you explain this transformation?
Yeah, happy to do it. When we started in 2008 or 9 at Berkeley doing research, we were working with these Silicon Valley tech companies and the problems that they had. And we got to see what they could do with data and AI. And, I think we were at Facebook, and Facebook, said they can predict couples breaking up in advance using machine learning. And we thought, wow, that's amazing technology. We would like to democratize that and bring it to every company on the planet. We open sourced Spark, and we were hoping that would transform all these companies, but not much happened. So we started Databricks in the hope that we can maybe commercialize it and we can bring it to all these companies. So initially, the goal was just make Spark win, make Spark become the technology that everybody uses. So that was the goal the first 2-3 years.
Yes,
so
exactly.
Only one goal. And at that time, now people don't remember, but at that time, everybody was going crazy about this technology called Hadoop. So that was our main challenge, was that we kept telling them, hey, there's this other thing. We said, no, but are you doing Hadoop? And so that was the sort of biggest trend of the time. So our first 2-3 years was just, how do we get people to wake up and realize this Hadoop technology is no good, and they should get rid of it, and there's the next generation of things that are much better. In 2015, we succeeded with that. So Spark kind of suddenly took over, and it became the sort of successor and the superior technology. So then we started sort of focusing on how do we, and that's around the time we did the CEO transition, we started focusing on how can we build a sustainable business model around this. So we went to large enterprises and we started asking them, we gave you Spark, so you have everything you need. You're done, right? You can go do AI and you can succeed. And it turned out that Spark was not enough for them, they needed many other things. They needed help with very basic data problems. Basic data problems that the big Facebook, Twitters of the world took for granted. or the PhDs at Berkeley thought are easy to solve, but they needed help with that. So we started actually building a technology called Delta, which simplifies and makes your data more reliable. So it goes back to the basics and just helps you with your data problems at its core. So we built that. Then we said, okay, now you have the data, you have Spark to do the processing, you have everything you need. But then it turned out they still needed help. They needed their machine learning folks that they had, the data scientists they had, still needed help to be more productive. They needed a way to track all these experiments, all the machine learning models they were creating. They needed to make them more trackable, more reproducible. So just basic operationalization of data science, they were struggling with that. So that's when we built MLflow, which was another open source project. So slowly we started listening to the customers and the organizations out there, and we built them what they needed to meet them so that they could make this sort of leap forward. So now we had built all these different technology stacks, but then people were saying, okay, we have all the pieces, but how do we put it all together? And that's when we started this journey of defining the data platform for them, which we call the Lakehouse, which is one place where you store all of your data in an open format. And then on top of it, you have integrated way to do data engineering, data science and machine learning, and data warehousing, all in one platform.
What is this data lakehouse?
Yeah, it's very simple, right? Everybody wants to do machine learning and advanced AI, right? I mean, in a nutshell, it's a crystal ball of predicting the future. If you had a crystal ball, would that be valuable to an enterprise? Of course, everyone would like to have that, but it's not that easy. Start by crawling and then walking and then running. So crawling is, getting the data, cleaning the data, starting with the data, and maybe just asking basic questions from your data, which is, what happened in the past? What was my revenue last week? Which of my customers left? Which product sold well previous month? So that's like the beginning of starting your data journey. But then eventually you want to graduate and start to do more predictive technology so that you can tweak the questions and ask, which of the customers will leave me in the future? What's my revenue going to be next month? These kind of
business intelligence, isn't it? I mean, this is the business intelligence.
Yeah, but now we're asking predictive questions about the future.
Oh, I see.
And for that, you need machine learning. And unfortunately, today, to accomplish all of these things, asking questions about the past and asking questions about the future requires completely different technology stacks.
Exactly.
For asking questions about the past, you need data warehouses. You can ask, what was my revenue last week? But if you're going to ask, what's my revenue going to be next week, you need data science and machine learning technologies. Completely different software, completely incompatible. And actually, you need to hire different people. You need to hire, for the first one, you need to hire analysts. For the second one, you need to hire data scientists. And these people, they're different background, different teams, different technology stack, but it's the same data. It's data on your customers and your products. So what we want to do is simplify that. So if you can bring all these technologies together into one architecture where you can store all your data, and you can ask questions about the past, what was my revenue last week, and about the future, what's my revenue going to be next week. Sounds simple, but the problem is, historically, it was really hard to accomplish this because all the data warehouses were based on this interface called SQL, SQL. And it's great for asking questions about the past, but you can't ask questions about the future. So we have to modify that to a different sort of interface that you can then use to both ask questions about the past and the future. So that's what the data lakehouse is. And that interface is called data frames. And once you have that interface, it turns out you can actually easily build SQL on top of it to ask questions about the past, and you can build advanced machine learning to ask questions about the future. So it simplifies basically data management for all these enterprises.
You took an early decision to be a cloud company, but now, of course, lately there has been a lot of discussion around data privacy, and people maybe move on-prem, etc., etc. What's your take on the whole infrastructure and delivery model arena?
Great question. Yeah, we took an early bet on the cloud. The whole business was built on the cloud. First 5-6 years, every pundit I knew, every expert I knew, and every go-to-market leader we would hire would tell us, you have to go to on-prem, you have to go on premises. That's where all the data is, that's where all the money is. But we kind of stuck to our guns and stayed in the cloud, and that served us well as everybody was moving into the cloud. Now, we're large enough that we could actually, if we decided, if we could go on premises, we could stay in the cloud, we could go hybrid. But I'm still more convinced than ever that the cloud is, we're going to stick to the cloud strategy. We're not going to go on-prem anytime soon. And the reason is simple. We can just make it much more secure in the cloud. We can make sure that we have people on call 24/7. We can do the monitoring. We can make sure that you get a great experience, even when it comes to privacy and security, compared to if I give you a CD, Martin, and you go install it somewhere on some data center that I don't have access to. And then if something is going wrong, if you're getting into trouble, if the data is being breached or you're having outages, you're calling me, I'm trying to figure out how to help you. It's better that the people that are building the software also manage the software. It also creates really good incentive alignment because we want the software to be secure. We want to have no outages. So we're incentivized to build it that way. So that's better than if I just give you CDs and you go run it off in some other environment. The other thing is, in the cloud, we can iterate faster. We can quickly see how people are using it. We can quickly upgrade the software. We can patch it quickly if there's a bug or if there's a security sort of, Log4j, vulnerability. We can patch it very, very quickly. Again, on premises, I would have to give you a CD and say, please upgrade to this version, right? So we can just iterate quicker. And also same thing, if we build software that's not great, you will tell us, Martin or Saif, that, hey, I didn't like this latest version that was released yesterday. And we say, okay, we just upgraded you again. Let me know if it's working better now. Again, on premises, we would have to wait for salespeople to come, convince you to get the new version, wait for you to install and upgrade to it. It could take 6 months. And then you might tell me it wasn't any good. And then I have to go again, work on the next software cycle, which might take 6 months. So it just lets you move very fast and iterate quickly. And that just, you end up innovating faster and creating better software. I think those fundamentals don't go away. So I think the cloud is here to stay. It's superior. I think we're going to see more and more movement into the cloud. But privacy is real. And there are more and more privacy concerns and regulations happening, not just in Europe, but also in the US and other parts of the world. And that is important for us. So we focus a lot on that.